Hi there, chemistry students. I'm glad you're here to check out the learning targets for our gas laws unit. This podcast covers both the states of matter, focusing on gases, and kinetic molecular theory, or KMT for short. As you work through this unit, you should develop a good understanding of the differences between solids, liquids, and gases. Like I said, we'll be focusing on gases here. Think about these states of matter in the particle form and in terms of the kinds of interactions that there are between the particles in each state of matter. I want you to move beyond just the basic definitions of solids, liquids, and gases to a deeper understanding of what effects the state of matter has on a substance's behavior and interactions. As you get deeper into the KMT, you'll see that there's a difference between ideal conditions and reality. Well, isn't that always the case in life? You should also come to understand why and how scientists use the ideal description of gases as a reference point to explain the properties of real gases. There are 5 parts to the KMT, kinetic molecular theory. They'll really help you zone in on what's happening with gases at the particle level. The properties of gases are the large-scale manifestations of the KMT. Have you ever taken a balloon filled with helium outside on a cold winter day? What does it do? Have you ever noticed that a non-mylar balloon deflates pretty quickly, usually within a day? Targets 4 and 5 relate to the most commonly observed properties of gases, things that perhaps you've come to take for granted as true, but do you know and understand why they happen? This part of the unit will help you with the how and the why. You will also develop a better understanding of how the properties of gases relate to each other and how a change in one variable affects the others. So there's a lot of laws mentioned here. Chemists love to find a mathematical relationship between and among variables. Well, they certainly did that for gases. These laws quantify the changes in pressure, volume, number of moles of particles, and temperature, and they're actually very easy to use. Targets 8 and 9 should come as no surprise to any student who is this far along in a chemistry course. Gases are tricky to trap and to measure. Gases can be cooled below what we would classify in our everyday life as freezing, air quotes. Those are just a couple of the reasons why labels and units are so important in this section. Chemists and chemistry students aren't always working with pure samples of gases. In fact, in a high school lab, that's hard to do. Our buddy John Dalton, who you will remember back from the atomic theory, did some important work on mixtures of gases and how the different gases in the mixture interact. He was even nice enough to quantify this interaction for us, and you'll see that, again, this is a pretty easy law to work with. Thomas Graham helped us understand gases even further when he quantified their rates of effusion. Effusion. That's a word you'll come to understand in this chapter, and you'll also learn how it relates to the property of diffusion. I always like to end the list of learning targets with some general targets that serve us well throughout the year. The chemistry classroom is a place for you to learn and to contribute to the learning of others, much like the collaboration that goes on between scientists throughout the world. Good luck as you start this unit. I think you'll find out that gases are fascinating and fun.